Hey guys, your homework should already be graded. You guys did that as a class. The next step here is to work on the warm-up. So go ahead and read the warm-up. We'll give you a couple more minutes, and then when everyone's ready, we will go over it. So the question reads, the ordered pairs, -1, 1, 0, 2, 1, 1, 2, -2, and 3, -7 represents a function. Which function rule could represent this function? So they give us the points. They want us to see which one of these function rules would represent all of these points on that function. So there's a couple ways of doing this. One of the ways is that I would probably just plug in the ordered pairs. So again, an ordered pair consists of an x and a y. So the first one's always the x. Second one is the y value. So if I look at this first problem, I'm going to plug in -1 in place of the x, and remember when I do that I put that in parentheses, and 1 in place of the y. So I'm going to put 1 in place of the y and -1 in place of the x. And if it comes out to be a true statement, I know that point is in this function. So I'm going to use my calculator. -1 times -1 is a +1. So I have 1 is equal to 1 plus 2, which ends up giving me 1 is equal to 3. Is that a true statement? No, it's not. So I know since this point is not in this function, I know I don't have to check the rest. Let's try this second one now. So the second one, the equation is y is equal to -x squared minus 2. Again, I'm just going to use this first point. Why not? And then we'll check other ones if it does work. So, the 1 is the y value. I'm plugging in -1 in place of the x. Remember that negative is in front of it, so I have to keep that in front. And then minus 2. So, 1 is the y value. -1 times -1 is +1, but this negative keeps it negative. I bring down that -2, so I end up getting 1 is equal to -3. Is that true? No. So A and B are already out just from plugging in that first point. Let's try this C now. So, again, y is equal to x squared minus 2. I'm going to plug in 1 for the y value, -1 for the x value, and I'm going to solve. -1 times -1 is a +1. 1 minus 2 ends up giving me a -1. Is that true? No. So this first point's really helped us out a lot because it's already canceled out 3. Let's check D to see if that's the correct answer. So again, y is equal to -x squared plus 2 is the function rule. I'm going to plug in 1 for the y, -1 in place of the x, bring down that plus 2. -1 squared is +1, but this negative keeps it negative. -1 plus 2 ends up giving me a +1. That's a true statement, so I know that is a point on this function. Now I would go and check all the points just to make sure, and then I would also double check it with my calculator. Remember, with your calculator, we're able to plug this function in and look at the table to see if these points are on that function. So whenever you get your calculator out, some of you may have already done this. I'm going to go to the y equals, and I'm going to clear whatever I have, and I'm going to plug in this function rule. So -x squared plus 2. Make sure you use the negative sign, which is down here, not the subtraction sign. And I'm going to go ahead and graph it. I always look at the graph. This is a quadratic. Okay, but again, I don't need to know that because I just want to see if these ordered pairs are on this function. So I'm going to go to second graph, which is my table, and I'm going to look for these points. -1, 1, that's the first one listed, that's on there. 0, 2, 1, 1, 2, -2, 3, -7. All of those points are on this function, so I know that my answer here is D. Okay, so again, always use your calculator to double check your work. So for today's class, we're going to continue with function rules. We worked on graphing function rules, so if I gave you this function rule, you had to graph it. So we talked about using our calculator, plugging in the points, sort of working backwards from what we did here. Then we talked about yesterday evaluating and solving. So I gave you an f of x equals the function rule. You had to plug in the x value to find the output. And today we are going to be writing function rules. So on the next page in your journal, go ahead and head that to 5, writing function rules. Today is September 27th. And go ahead and head your paper with the page number that's your next page number. In my case it's 44, and go ahead and label your table of contents. So here's 44. So I only have one left down here, which we'll finish up tomorrow. And as you're heading your journal, whoever's done first, or Miss Osborne, can go ahead and hand out this half sheet. And what you're going to do is glue this in right underneath where you headed this page in your journal. And when everyone's ready and has that glued in, then we will begin. So let's begin. Okay, we're going to have to write function rules today, and that means you're going to be given a word problem or an expression that you're going to have to translate from verbal to numerical. Okay, so we have to identify words that would represent slope to identify if it's a slope or if it's a y-intercept. And then also operations, adding, subtracting, multiplying, and dividing. They use different words that would tell us what operation we would have to use to solve the problem. So let's go ahead and start with slope. Okay, slope, again, is the same thing as our rate of change. So if I talk about some examples, let's say each topping on the pizza costs 50 cents. Okay, that'd be considered the slope because it's a rate of change. Every topping we get, it's 50 cents more. So the word there that I know would represent slope is each topping. Each hour that the workers work is an additional $30. Or every ice cream topping that you add is an extra $1. Or per. These are the three words that we'll see a lot that represent slope: each, every, and per. Now as you're identifying the slope, you have to keep in mind two things. If it's decreasing, so say the water in the tank is going down 5 gallons per minute, okay, that would represent a negative slope. So we have to make sure we identify the slope as being negative, and it works the same way as if it was increasing. Okay, increasing would be a positive slope. If we were spending money, okay, I'm going to put that also here, spending money, then that would be considered a negative slope. If I keep spending money, it's going to be taking it out of my bank account, which means my bank account total will be going down. Okay, y-intercept. Remember, y-intercept is going to be where it crosses over the y-axis. So again, it could say our starting point. So say you're hiring a painting company to come to your house. They charge you $100 just for the appointment, and then every hour they work is an additional $50. The starting point here would be the $100. That's their base fee that you have to pay them before they even start working. Okay, you also could hear it as the initial fee. When you're buying a house, you might have a down payment. You need to pay that first before you start paying your monthly payments, would be your slope. Other words that mean the same thing as all these would be a base rate. You could say the original amount. You hear the word first. or one-time fee. And there's other ones that you'll identify as we move on, but if you notice the similarities between all of these is just that one-time initial amount that you're going to have to pay. Okay, and it's not going to have to be repeated every time. It's just that one-time fee. And then as we're describing and writing these function rules from the word problems, operations come into play as well. So if I say the sum of 5 and 2, the sum of 5 and 2, what operation would that represent, the sum? Okay, sum would have to represent addition. So again, the sum of 5 and 2, it would be 5 plus 2. That represents the same exact thing. So I gave you the verbal sum of 5 and 2. You have to write it numerically, 5 plus 2. What are some other operation words that you know? What's subtraction? Subtraction would be the difference. Multiplication between two numbers would be the product. And division would be the quotient. Okay, so you have to know those. Those are something that you've learned in years past, so those shouldn't be new. Other words that you have to know is maybe it's 6 times a number. Okay, 6 times a number would be multiplication. It would be 6x. Okay, which represents another thing I want to write down. Put a star off to the side. Put a number would represent our x, or any variable. If they say, again, 6 times a number, we're going to do 6 times x, because a number that we don't know, we would have to use a variable to represent that. Another type of operation wording that they use would be less than. If I have 10 less than 20, that would be subtraction. More than would be what? Addition. When they use the word is in most cases, okay, that's going to represent equal to, or again, same. When we talked about our inequalities versus equations, when they have two sides that are the same, that would be considered equal. And maybe the last one, together, is probably going to be addition. And we'll see some more that we can add on to this chart later on. But this chart's great to look at as you're working on your homework tonight and as we're working through some examples of writing function rules. Okay, so before we actually look at some examples, let's discuss what a function rule is again. Remember, a function rule in this case is going to be an equation that represents all the points that are on the function. So we are going to be writing them into y equals mx plus b. This is the function rule that we're going to be focusing on now. And if you recall what these represent, you can look in your formula chart if you need to. What does the m represent? This is our slope or rate of change. And the v represents our y-intercept. Again, x is the input or the domains. Y's are the outputs or the ranges. We plug in the x value to figure out the y value. Okay, so we want to write everything into this function, this type of function for right now. You're going to learn other function rules later on this year, but for right now we're doing linear function rules. Y equals mx plus b for the most part. Okay, another word that you're going to hear is function notation. And we discussed that yesterday a little bit. And function notation is, instead of the y, what other things could they use that represents the same thing as a y? They could use this, f of x, remember? f of x. Function notation just replaces f of x for the y. It means the same exact thing. Okay, so you could put means the equation is a function, which means all the x values are different. So again, if I give you a function rule, y is equal to 2x minus 2. Another way that could be written is f of x is equal to 2x minus 2. They just replace the y and the x. It means the same thing. If they give you this first one, your xy table would look like this, x and y. This second one would be x, because again I have my x values, and I plug in the x values to figure out the y value, which in this case would be the f of x. So again, you could see your table is just x, y, or x and f of x, because that's a function of the y's. Okay, so again, f of x and y mean the same exact thing. One other thing is that we talked about yesterday is it doesn't always have to be f for function. It could be any letter. So if it says g of x is equal to 2x minus 2, okay, that's the same exact thing. It's just from my table, it's going to look like that, where it's x and g of x. So one thing you have to keep in mind is that other letters can be used. Instead of the f of x. You'll see g of x and h of x a lot. Okay, but the biggest thing between the function rule and function notation is that they're the same exact thing, except the y means the same thing as f of x. So put your triple star here and put y and f of x are the same things. And I'm going to highlight that too, because that's the biggest thing that we need to take away from this. And that should be already known to you because we worked on that yesterday when we plugged in our input to get the output. So we plugged in the x value to get what the output was. Alright, once you're done with that, on the next page or wherever you have a half sheet of extra space, you are going to go ahead and get this half sheet. Maybe someone can hand it out, and go ahead and take a second to glue this in. And when everyone's ready, we'll begin. Alright, so let's begin with these 4 word problems, and we are going to write the function rule from each of these word problems or sentences or statements. So let's look at the first one. Go ahead and take a second to read that to yourself. And I want you to highlight or circle important words. Again, we want to write the function rule for this statement. So think of those words in our chart that we just went over in the beginning of notes, and see if you can pick up on which one's the slope, which one's the y-intercept. Okay, so the question says a kennel charges $15 per day to board dogs. That's something I'm going to highlight, and one of the words that sticks out to me is the word per. So I know each day is $15. Upon arrival, each dog must have a flea bath that costs $12. Okay, now, this $12 represents, does it have to have a flea bath every single day? That's the question asking. No, it doesn't, right? It's just upon arrival, they have to have the $12 bath. Once they have that bath, they're done. They can stay for a week, they can stay for 3 days, it doesn't matter. So this is my one-time fee. Okay, so this would be my y-intercept. That's the initial fee that I have to pay. This would be my slope so far. It says write a linear function rule. Linear means what form does it have to be in? It has to be y equals mx plus b. And function rule means that it has to be an f of x is equal to mx plus b for the total cost of n days. So instead of using d for days, they use n. So put n for days of boarding plus a bath. Then find out how much a 10-day stay cost. So let's start by writing the function rule. Okay, so again, we know it's linear function rule, so it's f of x is equal to mx plus b, and they use n for days. So to write this out, I have f of x is equal to, again, my m represents my slope, so how much is it per day? It'd be $15 per day, so 15n. Actually, I should probably change this to n, shouldn't I? I'm gonna wipe that out, because that's what we want to find. We want to find the amount of days. So again, $15 per day. The b represents my one-time fee, or in this case my y-intercept, which would be $12 for that flea bath. So your equation here would be f of n, which represents days, is $15 per day plus the $12 bath. So that's the first thing. Write a linear function rule for the total cost. We did that. Next thing is find how much does a 10-day stay cost. So this 10 days represents that they want us to find when n equals 10. So using what we did yesterday in class, I want to figure out when I plug in 10 for n, what is the output. So the input's 10. I'm going to plug in 10 wherever there's an n for days, and I'm going to solve. So 15 times 10, $15 per day for 10 days is $150 plus the $12 that I have to pay for the flea bath. So my total here is going to cost me $162 for 10 days. So that would be my answer. Okay, what I want you to do now is I'm going to give you about 2-3 minutes to work on the second one. Again, it wants you to write the function rule to represent the situation, so you don't have to solve anything, you're just writing the function rule. So take a second to do this by yourself, check with your neighbor, and then when everyone's ready, we'll begin. Okay, some things I would highlight to start out with. It says the amount of fuel left in the tank is a function of the time spent driving. Each hour, 0.5 gallons is used. So that's something big here. And the tank started out at 35 gallons. Write a function rule to represent the situation. So they don't give us any letters this time, so we're just going to use x and y. So I know y equals mx plus b is the linear function. And I want to write the function rule, so they want me to use f of x is equal to mx plus b. So let's write our equation. F of x is the y value. Each hour, 0.5 gallons is used. So if I think about this, here's my tank of fuel. So say you're driving your car when you're 16 years old. Okay, the amount of fuel left in the tank. You use 0.5 gallons every hour. So the word each represents this is my slope. So if I use 0.5 gallons, that means I'm going to take that away from how much is in that my original gallon, or my original tank. So it should be negative here, because I'm using up 0.5 every hour. And my starting amount in the tank is 35. So notice I have 35 right now. I'm taking it away 0.5 gallons every hour. You could have wrote it also like this, where you could have thought about it this way, is I have 35 gallons in the tank and I take away 0.5 every hour. That's the same thing, because again, you just have to think about the signs in front. It's a negative 0.5x and that's a positive 35. So your equation here could be either one of these to represent the function rule for this situation. Okay, number 3, it says y, which is a number that represents a variable, is 5 less than the product of 4 and x. So one of the things that helps me is I just write down what I know. Y is going to stay the same. Is represents my equals to. This is 5 less than would be subtraction. Product is multiplication of 4 and x. So if I want the product of 4 and x, I'm going to multiply x and 4. Because again, I need to find the solution for that first. So this is sort of what I have. Now let's make it make sense. So y equals, y is 5 less than the product of 4 and x. So that's telling me I have to multiply 4 and x together. And then once I find the answer to that multiplication problem, y is 5 less than that. So I'm going to subtract 5 from the product of 4 and x. Now if I simplify this a little bit more, okay, this would be the correct answer. If I simplify it, y is equal to, instead of having that multiplication dot, I just have 4x minus 5. So either one of those is correct. One of the things you have to remember is when something's less than something else, that part always goes behind that part. If I would take away 5 from this, okay, it has to be after it. Okay, number 4, 2.5 more than the quotient of h and 3 is w. So again, I always identify is w means equals w. 2.5 more than is plus. Quotient is division of h and 3. So what this is telling me is w equals, because is w means that's what I'm solving for, 2.5 more than the quotient of h and 3. How would I show the quotient dividing h and 3? Okay, it would look like this, h divided by 3. So that would be one way. Another way you could have written this is w is equal to h divided by 3 plus 2.5. Because again, no matter what more than, it could be in front or behind. So one of those two answers. You're going to have more practice with this tonight on your homework. Just to refresh your memory on this. This is something from last year. A little bit more challenging though. So once you have that written down, you can go ahead and put your journal away. You will not need a separate piece of paper for your homework tonight. I'll explain the homework to you, so let's have someone hand that out, and we'll go over the first couple just so you know what I expect. So put your name, class period, and date on this paper. This is 2-5, Form K, Writing Function Rules. This is your homework, so if you look front and back, it's 11 questions. Some of them have multiple parts, so you need to make sure you're answering the question fully. Number 1 through 4, it says write the function rule that represents each sentence. So these are very similar to the last two that we did in our notes. 8 less than 1/3 of x is y. So all you have to do for me, again, I would write down some notes on what these words represent, and then once you have your final answer, circle it right next to that number. So we're not going to go over those because those seem self-explanatory. For the next couple, it says for exercises 5 and 7, write the function rule that represents the situation. Now these are very similar. They should be into linear function rules, but again, write down what you think would work best. So go ahead and read the problem and circle or highlight what's important. So the price P of a large cheese pizza is $7.95 plus 75 cents for each topping, which they use T for toppings. So they use T for toppings on the pizza, and they use P for the total price. So what we want to find here is P for the price. So it says P is, okay, $7.95 plus 75 cents for each topping. So to write this function rule, okay, I would find the slope. So in this case, the word each tells me that 0.75 cents for each topping. They use T for topping. And we have to pay for the original price of the pizza, which would be $7.95. So again, if I double check my work, $7.95 is the price of the pizza plus 75 cents per topping. Now if they give you these letters, you have to use them in your answer. Don't just use X and Y or that will be incorrect. Okay, so make sure you are watching that. So that would be my answer. I'm going to circle it and then I'm done. I'm just writing the function rule. That's for 5, 6, and 7. Okay, the last 4, 8 through 11, you're going to have to write the function rule. Write the rule that represents Eric's age A as a function of his sister's age S. And then you have to find out an extra step. So how old is Eric if his sister is 11? Okay, that goes for 8. Number 9, again 2 parts. Write the function rule. And then tell me how much the fees are for 15 downloads. Number 10, write the function rule. And 11 is write the function rule. So really only 8 and 9 have that extra part. Okay, when you're done, you're going to do this for homework. If you finish early, you can turn it in the tray and then just grab it at the end of, or tomorrow morning to put in the hot spot. And then work on this for the rest of the class period. And then whatever you don't finish is your homework. Okay, we'll go over this first thing tomorrow. Have a great day.